A car is negotiating a curved road of radius r. The road is banked at angle theta. The coefficient of friction between the tires of the car and the road is mu s. The maximum safe velocity on this road is. Okay. So what I'll do is I'll divide this explanation into two types. One, banking of road, okay, where the friction is not present, and then we'll discuss banking of roads with friction. So give me some time to draw a couple of diagrams, and then we'll discuss first banking of road without friction. Okay, so this is banking of road without friction. Now if there is no friction present here, if you draw the free body diagram, okay, let me first write down what are the given parameters here. So this angle is given to us as theta, and this, the radius is given to us as r. So we know that the forces acting on this car would be, the weight acting downwards and the normal reaction along being resolved in n sine theta and n cos theta, right? So these are the various forces acting on it. Now let us see the condition. Now what will be the condition here? We know that there is no net motion along the y direction, which means sigma Fy will be equal to 0. And according to Newton's second law of motion in circular motion, we can say that sigma Fx would be equal to the F centripetal, right? So let us first look at these two resolutions and then we'll write down the equations. Okay, now if sigma Fy is equal to 0, let us resolve the normal force into n cos theta and n sin theta. Okay, so I have not taken that diagram here, so to bring much clarity here. So we have n cos theta and mg along the y direction, right? So if we were to write the equation here, how will you write the equation? We can write that n sin theta, sorry, we can write that, okay, wait, we have not written it here. Okay, so we can write here that n cos theta minus mg is equal to 0. Therefore we can say that n cos theta is equal to mg, right? This is what we get for sigma Fy is equal to 0. Now wait, sigma Fx is not equal to 0. Why? Because sigma Fx is actually the centripetal force. Sigma Fx is actually, right? So sigma Fx is the, wait, what's, yeah, so sigma Fx is the centripetal force. Now what is the only force acting along the x direction? It is the x component of the horizontal component of the normal reaction, which is n sine theta, and what we have, the other force is F centripetal. So when we say sigma Fx is equal to F centripetal, there's only one force, and since it is acting along the net direction of motion, we can say that n sine theta, which is this component, is equal to F centripetal, and therefore n sine theta is equal to F centripetal, which is mv squared by r. Let us take this time as capital R, right? mv squared by r. Okay, now let us bring these two equations, which is n sine theta is equal to mv squared by r, the whole divided by n cos theta is equal to mg, and then we will divide these two equations. So what do we get? N by n is m1, sine theta by cos theta is tan theta, m by m is 1, and therefore what we left is v squared by rg, and therefore what is v squared? V squared is equal to tan theta rg, and therefore what is v? V is therefore equal to root of rg tan theta. Okay, so that's the maximum velocity. That's the maximum velocity which the car will turn on a banked road. But what is the condition? Banked road without friction. Banked road without friction. Okay, now let us see what happens in the case where there is friction. So when we discuss banking of road with friction, what are the various forces acting on it? Mg will act downwards. Then we have the normal reaction, which is acting perpendicular to the surface, which can be resolved into two components, n cos theta and n sin theta, and then we have the frictional force, which is acting downwards along the slope of the block or the banking, right? Now in this condition, let us apply sigma Fy is equal to what it is? It is m into Ay Is there any motion along the vertical direction? No, there is no motion along the vertical direction, which means acceleration along vertical direction is 0. This means sigma Fy is equal to 0. And what is sigma Fx? Sigma Fx is nothing but m into Ax, which can be here written as, F centripetal again. So let us now try to draw the free body diagram in a detailed way to find out sigma Fy and Fx, and this time I'll draw it more. I'll increase the number of diagrams so that the concept becomes more resolved. Okay, right. So now, see, let us first resolve friction. So this is the way friction is been acting in the along the slope, right? So if this angle is theta, right? If this angle here, see, if this angle is theta, which means I'm marking this angle over here, right? So this angle theta represents this angle theta. And if I were to resolve friction like this force here, can I draw a horizontal line here and then say that these two lines, okay, let me name these two lines. So maybe AB is parallel to CD, and therefore angle ABC and angle BCD are alternate interior angles, and therefore these two angles are equal, right? In which case I can use this triangle to resolve normal reaction, and these are two coincidental vectors now. So I'll travel from going from B to C. I'll go from B to A first, and then from A to C, and therefore I have the resolved components of Fr. And how will I write it? I will write them like this. So this would be, say this angle is theta, right? So this component is cos theta. So I can write here n cos theta. Now this component over is the opposite component, which is sin theta, and therefore I can write this component as n sin theta, right? Which means, I'm sorry, this is not normal reaction, right? This is friction. So I can write this as Fk cos theta, and similarly I can write this as Fk sin theta. Now the same concept when we discuss about the resolution of normal reaction. So we can say for example, draw perpendicular here, right? If this angle is theta, now see, we've been repeatedly telling the same derivation many of times, so let us not go through the same derivation again. So I can resolve this angle by vertically opposite angle. This will also be equal to theta, right? So if this is theta, vertically opposite angle, this angle is also theta. Now if we resolve this normal reaction, how can we write this as? We can write the normal reaction as, say, so this is the adjacent side, so this will become n cos theta, and this is the opposite side, so this will become n okay, sine. If you want, let me draw that one more time. See, this is the normal reaction here. Normal is acting like this, right? So can be resolved into two components, one the vertical component like this, and other the horizontal component like this, where this is theta. So this component is the opposite component, so that will become n sin theta. This is the adjacent component, and therefore that will become n cos theta. Simple. Okay, now having said that, let us see the condition. Sigma Fy is equal to 0. Now why is sigma Fy is equal to 0? Because there is no net movement in the y direction, therefore acceleration along the y direction is equal to 0, and therefore sigma Fy will be equal to 0. And now if sigma Fy will be equal to 0, let us see what are the various forces acting in the y direction. There is one component of Fk acting in the y direction, which is Fk sin theta. So let it over here. We have Fk sin theta, and there is one component of normal reaction acting in the upward direction, which I'll write it here as n cos theta. So therefore from this condition we can write that if sigma Fy is equal to 0, we can write that n cos theta is equal to Fk sin theta. Now what is Fk sin theta? What is Fk? We can therefore write that this is n cos theta is equal to, see, what is Fk? Fk is nothing but mu k into n into mu k into n into sin theta, right? So this is the condition with y direction. Now let us see what happens when we come to x direction. Okay, so one more time we will try to see the concept of resolution in detail. So what we have here is the plane road, the banked road, friction is acting downwards. Normal reaction component cos theta sin theta, which means normal reaction is acting like this, right? So we have normal reaction acting like this, okay, right? And when we discuss about the horizontal forces along the x direction, we therefore need the F centripetal, because by Newton's applying Newton's second law in circular motion, we can say that sum of forces in the radial direction is actually equal to the centripetal force. So this is a centripetal force acting into the center of the road, right? Acting into the center of the road, where n sine theta acts along it. Now we need to resolve the frictional force into horizontal and vertical. So as we did in the previous section, this is parallel line. These two are parallel lines. Let me write them one more time. So we have AB is parallel to CD, and therefore if you assume this FK as the side of triangle BC, then we can have triangle ABC, right? We can have triangle ABC. Okay, that's been already explained, so let's not waste time here. So we can write this part as FK sine theta, and we can write this part as FK cos theta. And normal reaction, we have already resolved it. What we have is this part as n cos theta and this part as n sine theta. Now see, there are two forces. One is Fr and the other is normal reaction. What is the x component of normal reaction? It is n sine theta, right? So n sine theta acting towards the left is one component. And for the frictional force, we have one more component which acts towards the left, which is the Fk cos theta. Fk cos theta is acting towards the left, and therefore we can write here as Fk cos theta. And if sigma Fx is equal to F centripetal, then what can we say? See, since both of these two forces and the net direction of motion is actually along the same direction, right? Along the same direction. Therefore we can write that. Fk cos theta plus n sine theta is equal to mv square by r. Now what is Fk? Fk is nothing but mu into n. So we have mu into n cos theta plus n sine theta is equal to mv square by r. Okay. Now let us bring these two equations together and then try to solve the unknown variable, which is v here. Okay, so n sine theta plus Fk cos theta is mv square by r. We got it from solving the forces along the x direction. For y direction, we have n cos theta is equal to mg plus Fk sine theta. And we know what is the value of Fk? It is mu k into n, right? What's the value of Fk? It is mu k into n. Now, how do we solve this equation? So for that, what I'll do is I'll rewrite this equation as n cos theta minus mu k into n sine theta is equal to mg. Which equation? This equation over here, right? And then I'll bring this equation over here. Then what we do? Then what we do is we divide these two equations. So let us see what do we get while dividing them. So when we divide them, what we get is n cos theta minus mu k into n sine theta, the whole divided by, now see, I'm going to do a small algebraic manipulation here, the whole divided by n sine theta plus mu k into n plus mu k into n cos theta. Okay. Now the LHS remains the same, which is m into g divided by mv square by r. And here what I'll do is I'll divide this entire equation by n cos theta. So I'll divide this entire equation by n cos theta. Okay, so I'll divide this equation by n cos theta, this equation by n cos theta, this equation by n cos theta, and this equation also by n cos theta. Now let us try to understand what happens. So n cos theta by n cos theta is 1, so this becomes 1 minus n by n is 1, sin theta by cos theta is tan theta. Everything remains the same, 1 minus mu k into tan theta, the whole upon n by n is 1, sine theta by cos theta is tan theta, plus n by n is 1, cos theta by cos theta is 1. So all we get is tan theta plus mu k is equal to mg into, okay, now wait, now we have m by m is 1. So all what we have is g by, sorry, is v square by r, so that becomes gr by v square. In which case, what is v square is equal to? V square will then be equal to tan theta plus mu k, the whole divided by 1 minus mu k times tan theta into rg, right? And therefore, what will v become? V will therefore become root of tan theta plus mu k into rg, the whole upon 1 minus mu k tan theta, which brings us back to the question, which gives us the answer to tan theta into rg. So rg mu s plus tan theta by 1 minus, okay, so this gives the correct option as option A. Okay, that was a lengthy solution because see, it becomes time consuming when we try to elaborate each and every step. So, which in this case was resolution of forces, which is the key point in understanding the understanding the question here. Without which it becomes really difficult. Now, those people who have attended the class, otherwise they know directly that the formula is rg into mu plus tan theta. We have been discussing this many times in the class, but others who have missed the class and those who are watching online, please make sure that you try to understand the derivation, derive it a couple of times on your own, and then things will become more clear to you. Okay, typically not a NEET level question, I have to say that. Typically not a NEET question. It was a bit time consuming. Even if you were to do it in the exam hall, or simulation, it will take at least 2 to 3 minutes when you're doing it for the first time. Okay, let's now move on to the next question.